right? So now let's go to the next part of it here. So next thing what you find here, let me get to the another one. Let me first explain that, then I'll give you the AWE, atmospheric wave experiment. This will be more better. Now it is visible to everyone in the class. See, for writing I can use the normal kind of thing there, but for explanation I can use this one. Atmospheric wave experiment is another NASA mission there. American Space Agency, NASA's mission, atmospheric wave experiment. Now let me explain here. Sometimes NASA may use satellite system to study atmosphere. It's basically about atmosphere system there. And you know that you have read about in geography something called aurora. We have a air glow, aurora borealis, and that happens in ionosphere, where have a lighting in the sky, air glow. What is something called air glow, and that happens because of interaction of charged particles coming from outside space, right? So it is like this one. See here, interaction of terrestrial and space weather. Let me make you understand. Solar flare, sun flare. Nowadays it is all making news when the sun emits the powerful waves and the flare, and that comes to our atmosphere. So in the ionosphere, when the interaction happens, there is something glow, what you call auroras, which glow there. To study this one, there is an experiment called AWE. There is NASA experiment called atmospheric wave experiment. That is colorful bands of light in Earth's atmosphere, and that is because of the atmospheric gravity waves that they have done there. So let me just give you the main part of it. Let's understand here. Just understand here. What do you have to keep in mind here? I'll give you in a flowchart form here. Atmospheric wave experiment. First thing here, just you can write there, it is a NASA mission to study air glow in the outer atmosphere. Right? Whatever the glow is there. Now what is done here, second thing is that study interaction of solar flares with particles of ionosphere. Right? Particles of ionosphere. Now it also study glow caused by thunderstorm. Right? Sometimes thunderstorms and all, we have a lightning in the sky. You have seen that lightning there. So that again it can study those kind of interaction. It can study such kind of interaction there. Right? This is just to keep it that. Another thing is what is fourth thing here? Study of you can write there atmospheric, which is very, very important from astronomy point of view. Atmospheric gravity waves. Now tell me from where these gravity waves are generated. Gravity waves. It will also study the gravity waves in the atmosphere. So in the atmosphere, from where the gravity wave will come? Who has given this concept of gravitational wave? Albert Einstein. Which theory talks about gravity waves? That is a general theory of relativity. When there is a change in space-time, right? When there is a rapid change in space-time, right? That generate a kind of a wave which is called gravitational wave. So even that interaction part will be caught by this spacecraft. This is a spacecraft, AWE, which will be studying that one. What is three things here? One is the solar flare, interaction with the atmosphere. Second, thunderstorm lightning. And third is atmospheric gravity waves. Three main points. Just main point you have to keep in mind. And what is the fact here? NASA mission. That's it. So if, let's say, if you're doing right now in the classroom, then you don't have to mug up. NASA mission, three things. Sun, space weather, atmospheric gravity wave, and third is the thunderstorm lightning, air glow. That part I have just put across there. Right? Clear there? And I'm very happy that you all are here. Last time you were there. So few people are new to the class, but others are, you were not there. You are new to the class, but other people were there. So we will be able to cover a lot of things there. So, but don't worry, I will be trying to give you the maximum thing, because now is like almost like a marathon, because you have to cover a lot of topics. One by one can cover that. And you are spending your precious time. So what I request every one of you, both in the class and also in Zoom session, to make best use of this time, so that this topic you don't have to read again. It should be in your brain. If any question comes, AWE, you are aware what is AWE, atmospheric wave experiment, right? This is a scientific experiment here. Now let me go to the next thing here. So this part is clear here. So I'll go to the next page here. So next page, if you come across, that is this one. I've already given as there's a CAS GVY is there. GV is there. You can do the Y there. Okay, now let me go to a very important thing here. World's first near space command. Let me explain here. GVY is there. CAS GV. Now let's look at here. Let's understand. Now this could be one of the question from defense point of view. Let me make you understand here. See, if you look at Earth, we have atmosphere there. What is the first layer? Troposphere. Then comes stratosphere. Right? After stratosphere, mesosphere. "80 kilometers to 100 kilometers, mesosphere." Right? China has created a space command network. Now let me ask you a very simple question. When we are on the Earth, we have a very important aviation sector where we have an aeroplane flying in the air. Now tell me at what height normal domestic or international airlines flow there. You know, they also move there. What should be the height? Normal aircraft, which we come aircraft, where it flies there? No, that is a part of stratosphere or troposphere. It goes to stratosphere. Lower stratosphere, not upper. 35,000 feet. That means 12 troposphere to go to that upper part. 12 to that 20 kilometer range. That is where the airlines move. Even fighter jet. Military air force have the fighter jets. Indian Air Force and worldwide military air force, they use a fighter jet. Where they are used? This one. There's something called airspace. Airspace. Let me explain here, because this could be one of the question. Airspace. Now, airspace is one of the frontiers. As we have a land frontier, land, water, air is also frontier. Like that means, let's say over India, we have an air above there. So government of India has a sovereignty over the airfield above India. That means the government can allow or deny any kind of movement of aircraft over the airspace of India. Similar is same with China, Japan, USA, South Africa, Brazil, any country can do it. Right? Now this is controlled by governments. Governments worldwide, they control this airspace. So during the time of conflict and war, that during the war and conflict, what they do, they don't allow any enemy aircraft to flow. Let's say if India has a problem with the neighborhood, then what will happen? They will not allow any kind of a aircraft to move in the airspace. But when you talk about this one, 100 kilometer above, right? 100 kilometers above, that is what is called outer space. And you know that outer space has no sovereignty of any country, right? If we talk about outer space, there's no sovereignty of a country. Of any government. That means outer space belongs to everyone, right? Everyone has the outer space there. Now what is the now new thing is coming? China. China has built a space command. So what China can do there? One second. What China can do there? Right? Tell me here what China can do there. If China has developed this kind of a near space command, so what will be the part of China? China will use for military purpose. China can use even the missiles to attack. Right? Now remember that. Where is outer space? Now see here. This again, everybody knows where is outer space? Above 100 kilometers. Where China has built? 80 to 100 kilometers. See, this is a gray area. See, China is very smart. Where the government can control? Stratosphere. And where international level control of space is there? After 100 kilometers. There is something you will come across Karman line. After Karman line. 100 kilometer Karman line. So outer space, there is a treaty called Outer Space Treaty. And what does the Outer Space Treaty says? Peaceful use. Try to understand. The Outer Space Treaty says 1967 there is a treaty by the governments that outer space should be used for peaceful purpose and there should not be any weaponization. That means China cannot use any weapon in the outer space. So what China smartly did has built a command in between this one where there is no international law. Are you getting there? Where the international law comes, either airspace, there is international law, or there is international law in the outer space. This area is open. Are you able to understand this? Are you able to understand that this is called what China has smartly developed a space command in mesosphere where there is no international law or there will be no control over China by any UN body or any kind of a agency. Cannot control. Now this is a risky zone because China can do anything from the mesosphere. Did you understand that? Now tell me, I'll ask one more thing here. This airspace in stratosphere is controlled by which body? So both the bodies are there. There's something called this one. International Civil Aviation Organization, where governments are the parties there. Are you able to understand? Civil aviation. And here, outer space. Where is outer space? After 100 kilometers. So which body control outer space for peaceful purpose? There is a body called as a UNUSA. What is the full form of UNUSA? United Nations Office on Outer Space Affairs. I'll repeat again. United Nations Office of Outer Space Affairs. That is outer space there. Are you able to understand? But there is no law, there is no body for mesosphere. China has developed there. That is what the smartness of the dragon is there. Right? Where there is no law, no international law, there is no restriction. China built that. But that is could be a danger for the entire world. Did you get that? So here, China has built here this one, Near Space Command. In between. Now, tell me what all use can be done. This one. One use can be this one. Surveillance. Keeping an eye of development. Second could be what? Military. that is weapons. Even one can use such kind of a rocket or missile, which can be hypersonic. Hypersonic means 5 Mach to hit the target anywhere on the earth. Even that could be done from there, right? So this is where the future scenario could be there. So just only to make you understand, I have drawn the diagram where the mesosphere comes, right? Now one more application could be there, communication. Communication system. In future, China will develop the communication network using the mesosphere. That could be the another part of China's development. Clear here, right? So I'll just move to the next topic so that I'm able to cover the most topic there. All right. So I'm just changing that one. Have you covered in your current affairs classes this one? All this topic? No. Anyway, not a problem there. Sickle cell disease I have explained there. Now let me come to this one. Earlier, America 2019 created Space Force. See, you remember that. USA created Space Force, but not command. But China has created world's first command. They've created Space Force. So China has taken one step further. You'll see here. 2019, United States created Space Force, dedicated military branch tasked with handling threats in space. But now China is building the control system there in mesosphere. That's what comes here. Now here, which I have, that this I have covered the last time, but again I'll mention that. That Aditya mission. We have Aditya mission, Aditya L1 mission to study sun and the sun's corona. And we have discussed one word called coronal mass ejection, CME. Even now also it is in the news that after 20 years, very powerful waves are coming from sun, right? And the second thing, what is very, very important here, that is in terms of NASA's mission there. Now tell me, what is the name of the spacecraft of NASA which deal with the study of sun? See, we have Aditya. We have Aditya Lagrange point 1, which we have done that. Which is the NASA's mission on study of sun? I have discussed last time also there. One was the Parker probe was there. But there is a Lagrange point 1 L1. NASA also has a spacecraft. What is the name of the spacecraft? It's named after a movie where Prabhas was the actor. But that movie was a flop movie. Can you guess what is that name of the movie? Prabhas, you know, na? Bahubali, Salar, right? He made a movie which didn't work so well. Soho. Saho or Soho? What was that? It was SAHO or SOHO? Huh? SAO, sorry. I thought this is SOHO. Saho was, okay, sorry. That is Saho. But the spacecraft is called Soho. SOHO. Solar, let me write there. Coronal mass ejection and all. So let me just briefly tell you the fact here. Let's look at here. See, when you come to coronal mass ejection, all this is making headline. So just be prepared with this topic. Now, what is very important here? One is this Aditya. And you remember that last time I had given you that flowchart and everything, instrument. Remember the 7 instruments? I have given you that kind of which instrument has got what type of function. I made a flowchart on that one, right? So Aditya, that is a part of ISRO mission, Lagrange point. And second thing which comes here, that is what is called SOHO, Solar Heliospheric Observatory. Now this is also in Lagrange point. Now this is by NASA and ESA. So if you look at this kind of Lagrange point 1, there are only 3 countries, right? US, European Space Agency, European countries as a group, and third is India. And both are for coronal mass ejection, CME, solar flare, solar wind, for study of that. So that was making a headline here. So we have already covered that Aditya mission and this part of this, but SOHO just keep in mind. And how it is possible to keep it L1 point, both of them? SOHO was L1. How it is possible? I discussed about there's something I have discussed in the classroom. Halo orbit, very good. 3-dimensional orbit there. Right, will rotate about that point. It's not a particular point. Remember that the spacecraft is not on a point. It goes around that point. So there, both of these are working. And even now, we are taking the help of Europe, ESA, in terms of our Aditya mission. We are getting the support from Europe in terms of this mission program. So that was in the news, and now recently NASA has been studying coronal mass ejection. See, whatever information we get nowadays, they come from NASA center. But now, Aditya is also prepared for it, and there we can get the information, right? So these are two areas which you just keep in mind there. Now let's look at the another part of it. This coronal mass ejection, Now from where the coronal mass ejection emitted? Sunspot. What is the one word here? Sunspots. Outer corona has a millions of degrees centigrade temperature, and that's magnetic effect which generate powerful wind and waves. There's two things are there. One is solar wave flare, and second is called solar particles, the wind. So you see here this solar wind stream of charged particles, and solar flares, that is a wave radiation. Did you understand? The two terms are, one is particles, second is a wave. And that impact space weather, satellite, our all impact could be there. So that is where it is given here. Impact, it was asked in UPSC exam. Aurora, I have mentioned aurora, lighting in the sky. Second, what will happen? The communication satellite, navigation satellite, all will be blackout. There is no signaling. Third comes here satellite damage, navigation system error, and astronaut who are living in the outer space. Where they live? ISS, International Space Station. They may have a health impact if they are outside and they get the flare. So that's what comes here. So this is what given here. Now this also I have discussed last time. You remember that Ladakh dark sky reserve is India's first dark sky reserve. Now I have also mentioned last time, there's one national park also becomes a dark sky national park. Pench. So there are two Pench. One is a Maharashtra and second Pench is a Madhya Pradesh. The Pench in Maharashtra, there's also Tiger Reserve. It also has been declared dark sky. Now my question, GK question, last time we have covered in the classroom. The Ladakh, where we have created dark sky, where in Ladakh we created dark sky. What is the name of the place in Ladakh? Where we have a telescope. What is the name of that place? Hanle. 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 Hanle, Ladakh. Right? There's a place where India has a telescope. And there we have created dark sky reserve. Now yesterday, yesterday was International Year of Light. Even there is an International Year of Light. And the same light has now become a problem for human beings, for animals. Even it comes in environment also there. See, light pollution is three part. One is astronomy, right? Science and technology. Second comes environmental aspect, right? Birds and all this animals getting affected. And third is human. Our impact because of the light, the glow part of it. So just remember that Hanle, what is the name of the place? Hanle, 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 Ladakh. We have India's first dark sky reserve, total dark, right? This has been given here. International Dark Sky Association in the US, they have done this. India's first dark sky reserve. This is a part come Chengthang. We'll discuss about Chengthang in environment also there. Okay, anyway, let me ask there. Tell me from environment and ecology about Chengthang. See, this is the one part, astronomy part. Indian Astronomical Observatory, Hanle. But now tell me about Chengthang, other thing, what you know about Chengthang. See, UPSC is very smart, right? From UPSC knows that students are aware of dark sky reserve. So UPSC might not ask question. I'll tell you that. UPSC might not ask this question. UPSC may ask you question from astronomical aspect or UPSC may ask from environmental aspect. Okay, let me write here. Let me give you some very important thing here. Astronomy part, you understand dark sky. What is dark sky? The night will be totally dark. So that we can use telescope to study the universe, galaxy and everything there. But now let me give you this. Chengthang is a very important place in Ladakh. One is there, this one you'll come across. Recently, there is a Ramsar site declared in Ladakh called Sokar. It's a complex of wetlands. That is Changthang. Second, you will come across this one. And both are Ramsar sites. What are Ramsar sites? These are the wetlands of international importance. And why they are declared? They are declared for biodiversity. So Ladakh has got two Ramsar sites, Sokar and Somoriri. And where they are located? Changthang, Leh Ladakh. Right? Now I'll give you another aspect of here. So there is a snow leopard conservation Changthang sanctuary. There's a wildlife sanctuary. See, in Ladakh there are two sanctuaries. You should remember the two sanctuaries. One is called Hemis, Hemis, and second is Changthang sanctuary. Right? Now I'll give you another very good understanding from there. Recently, right, one another very important thing which made a headline. You know, anybody can guess there? There was another animal which made a headline. See, snow leopard you find everywhere. Where you find in Himalayan range? Ladakh, Uttarakhand, Himachal Pradesh, Sikkim, Arunachal Pradesh. That means Himalayan range. But there's one animal which is found in Changthang and also found in Arunachal Pradesh. These two places are found. It was recently in the news. Can anyone tell me here? Now let me give you a hint also. It's a bird. It's a migratory bird. Black-necked crane. Where do you find black-necked crane? One is a Changthang. Another one you'll find in Arunachal Pradesh. This is a migratory bird. It's migrate. Right? It's a migratory bird. And according to, and see how you can remember that. Such kind of facts you can remember like this. Snow leopard and black-necked crane. I'll give you a common thing. Both are vulnerable. You know, I used to read it a book. What is vulnerable? Vulnerable means more than 50% population decline over the last 10 years, 1 decade. 50% population has declined. Black-necked crane is a migratory bird, is also vulnerable, and snow leopard also, Another thing is what? Both of these species are found in Arunachal Pradesh also. And I'll give you the name of the place, Namdhapa. Namdhapa. Arunachal Pradesh has got a very important place called, yes, Namdhapa. There also this bird. Normally people think black-necked crane, Ladakh. But I'm giving you a very important fact. This bird also migrate to Arunachal Pradesh. They also found there. Right? Now where this bird lives? Wetland. What is wetland? Water bodies. This is water body. There this particular bird lives. Right? It was earlier declared as a state bird of Jammu Kashmir. Earlier J&K and Ladakh was as a one state was there, but now it is union territories. The state bird was there, and this bird has a religious importance. So now tell me, which is a very important religion in Ladakh? Buddhism. Is linked with the Buddhism. This particular bird. So which all countries this bird will migrate? One is India, Ladakh. Which is second country? China, Tibet. Right? And third is Bhutan. Bhutan is again part of. So India, China, Bhutan. You can write there. It is basically found in India, China, and Bhutan. And very interesting thing is that again India, China, Bhutan, you'll find snow leopard also. Snow leopard is found. Now tell me another thing. I'll just add the environmental aspect. Recently there was a census of snow leopard, And highest population of snow leopards in India is found in Ladakh. Ladakh has got highest number of snow leopard also. And snow leopard you will find in China also. Himalayan range, where you find snow leopard? Himalayan range, right? Kyrgyzstan, the Central Asia part. And also snow leopard you will find in Namdhapa. Where is Namdhapa? Arunachal Pradesh. So that is again the part of it. Again, what is very important here about Changthang? About Changthang, another one here, which I am giving here. World's tallest mountain top optical communication system. World's tallest, on the mountain top. This system has been developed. See, Ladakh is a cold desert. What we call as a cold desert, right? And cold desert, area is just like you have a landscape there with mountains, hill, valley. So there it has been done there. And you know the person? Sonam Wangchuk, who was recently with 21 days climate fast. He held a 21 days climate fast. So now UPSC will not ask you the climate fast or Sonam Wangchuk. But what is the place? Changthang. So this way you'll remember Changthang. You'll not forget Changthang. And the same place, what has been now brought? Dark Sky Reserve. So we have a telescope also. See, so many areas I'm connecting here. So even you know this is also Dark Sky Reserve. So now Dark Sky Reserve is part of astronomy. So I've connected the topics there. Right? These are points you have to remember from the exam. And UPSC can go into any such area, can ask you a question. Right? All these are facts there. Is it clear here? So that's what I brought here. Sonam Wangchuk and this person here who's done the innovation, developed this kind of system there. Right? So that part you have to just keep it in the mind there. And out of 80 Ramsar sites, we have 2 Ramsar sites. Ladakh was having earlier Somoruri, but now it has a Sokar. They brought there. Alright. We will be covering that. Ramsar site, I will be covering that. Which all points you have to keep in mind. Just remember that. Shall I change the page? All I've done there? Back side? Alright. So try to learn right now only. Whatever I'm trying to make. If I've copied, then I'll change it. Right? All I've done there? Alright. So now let's look at here. Is it clear here everything? Now see here. This we have already covered in the classroom. If you remember that we have discussed ExpoSat, this mission. Last time you remember the X-ray polarimeter satellite launched by India, and that was the 1st of January, the beginning of the year. ISRO successfully launched this one, and it is India's first X-ray polarimeter based satellite. And where we have placed it? Low Earth orbit, 650 kilometers. So 650 kilometers we have. So ExpoSat. And how many instruments it carries a payload? 2 are there. One is Pollux, and second is a XSPECT. I'll write it down there. One more thing which you remember that I have discussed last time, POEM, POEM, PSLV. P is the PSLV, Orbital Experiment Module. That means last stage of PSLV. You know, PSLV is 4 stage, solid, liquid, solid, liquid. Last stage became a platform, right? Platform to conduct experiment. If you remember that, I have explained you how that system work. It can lower the orbit, conduct the experiment. So that was linked with which mission? ExpoSat, right? Yes. No, yes, most of the people were there. That's why you are the new to the class, that I know that. So I'll write on the board, but those were there in the classroom. That's what I'm trying to recall them. Okay, the last time we have done that. So now let me come to this one. So is it clear here, this one? So what are the key points? See here, key point is this one. Let me get to the main points of it. So what is very important here, I'll make in a very summarized form. Five important missions which you have to remember for this exam. and I'm giving you in a flowchart form all key points here. The first point which you have to know, that is this one. So we had 1, 2 and 3. Now where India is going for? We are going for Chandrayaan 4 mission. There's a plan there. Now anybody in the classroom that last time we have there, what will be very unique in Chandrayaan 4 mission? See, Chandrayaan 1 was orbiter. Chandrayaan 2, 3 was orbiter with lander. But we failed in landing part, Chandrayaan 2. In Chandrayaan 3, we had soft landed, right, on the south pole of the moon. So what will be Chandrayaan 4 mission? Sample, this one, to collect sample, to collect a lunar sample. Now this is what we are planning in the coming time. We will collect the sample there. And I have also told in the classroom that we are collaborating with Japan, JAXA. Now tell me, recently JAXA, I'll write here. Recently JAXA has conducted one very important mission similar to Chandrayaan 3, SLIM. Yes, smart landing. I is an information module, right? Investigation module. Smart landing investigation module. So what Japan did, it also developed a kind of lander and also soft landed South Pole there. But the lander was 10 times less in the weight than our Chandrayaan Vikram lander. It was very lightweight, which was landed on the moon, right? We did with a very heavy one. They did with a small one. And it has a 2 rovers. SLIM had a 2 rovers which moved on the lunar surface. So this is one thing here. Now second thing here. Second, what is very important thing which we have discussed right now? Aditya L1 mission. Now what is very important here? How many instruments are there? 7 instruments is a payload. You remember PAPA, plasma analyzer for package for Aditya, right? We had a chronograph, VLC, to study the corona of the sun. So here, this is the, what are the things are there? One is this one, corona. Second is what? We have discussed right now, coronal mass ejection. And third is what? Third is this one, space weather. How that affect the space weather? Aditya and Lagrange point 1. How far is Lagrange point? 15 lakh kilometers away from the Earth. Hello orbit, right? So that we have done. Now third one. Third is what is very important thing? NISAR. Now it is going, we are now next, we are planning for NISAR mission. What is NASA? What is the full form here? NASA, ISRO. We are collaborating with USA there. And what is this? SAR stands for synthetic aperture radar. Synthetic aperture radar. And it will be launched by India, Sri Harikota. Which rocket we are going to use it? GSLV. GSLV Mk2, Mark 2. Remember that. Which is the heaviest rocket in India? Mark 3. But we are going to use Mark 2 to launch it there. And what is another thing here? It has got L band. You remember that? L band and S band. These two polarimeters are there. L band has been given by which agency? NASA. And S band by ISRO. And what are the primary objective of this NISAR mission? Earth's environment, right? Ecosystem. Changes in ecosystem. Then again, forest fire. So I'll write here. The first is that what? This one. What is cryosphere? Polar areas, Arctic, Antarctica, mountain glaciers. And you know that because of global warming, climate change, it is melting, right? That we are going to study there. Then I'll take it upward here. People who cannot see, I'll just take it upward. So now it is observe. Now what is second study here? This one. Water cycle. Global water cycle. What is happening with global water cycle? Flood, drought, all these are part of is happening there. So we'll be studying those water cycle, and it has a direct connection with what? It has a direct connection with agriculture, food security, and this one. What is third thing here? Third thing is this one. So what type of disasters will be studied by NISAR? One is earthquake, landslide, forest fire. All these are calamities, no? Will you? What type of satellite is that? Earth observation. Will observe the earth. Then again, another thing is this one. Interior. Now you know that in geography I've studied, earthquake is caused because of the movement of the plates, right? Wagner theory. So we will be able to understand the seismic nature of the earth, and maybe possible we can even predict earthquake. And one more thing is there, where the NISAR will be used. Any idea where NISAR will use? Ecosystem and biodiversity. You write here, changes in forest, changes in grassland, and also in terms of wildlife. So I'll repeat, there are 5 main objectives of NISAR mission. Study of cryosphere, polar areas, mountain glaciers. What is second objective? Water cycle, which will connect with the agriculture, right? How the water cycle is changing because of the changes of human, and at the same time the global warming climate change impact. Third will be disaster, natural calamities, forest fire, landslide, earthquake, flood, drought. Fourth will be earthquake, changes in plate movement. And the fifth one is how the forest, grassland are changing because of the changes in the environment, and how that impact the biodiversity part of it. These are the 5 objectives of NISAR mission that we are planning there. Now next, what comes here? This mission, X-ray polarimeter, and this is India's first one, satellite there. Now tell me which rocket we use for XPOSat? PSLV. There's a poem. So we use PSLV rocket. And what is very important here? 650 kilometer low Earth orbit. We are placing 650 kilometer low Earth orbit, where the XPOSat is working. And what is very important here? It has got Polix and X-spect. These are 2 X-ray spectrum, right? Emission. This telescope is there, and the another one is a polarimeter, X-ray polarimeter instrument, the Polix. And what are the objectives here? XPOSat we have discussed last time. What XPOSat is studying? Black hole, neutron stars. So it will be right here. So the objective is this one: black hole, which is there in the universe there. Then study of neutron star, because all these emit what type of radiation? X-rays. Quasar. What is quasar? Is a magnetic star which generate the radio waves. So here quasar. I repeat here: black holes, neutron stars, quasars, right? Supernova and all those kind of things there. So that is in terms of astronomical research. Now I'll ask a GK question. Which is India's first satellite to study such kind of thing? Black hole and stars and everything. First satellite in India. You see, XPOSat is not the first. Which satellite India has launched to study astronomy from space? Again, black hole, supernova, neutron star. ASTROSAT. What is the name? ASTROSAT. Which year? 2015. We had a ASTROSAT, ASTRO, ASTROSAT, India's first astronomical satellite, right? So that was in 2015, again by PSLV. And now tell me, which is the fifth one, very important mission of ISRO? Gaganyaan, human space flight. That's the Gaganyaan. Human space flight. And we are planning for next year. And you already know that we are going to use this one. Launch vehicle Mark 3. That is a GSLV Mk3. And you know that it will have two modules, crew module and service module. Astronauts will be placed in the crew module, and that will be supported through a service module. We have planned for how many astronauts? 3 astronauts. But now, you know, 4 names have been announced. 4 names have been now given. Astronaut wings, the astronauts have been there. But the plan is to send 3 of them. And I have also discussed one type of humanoid, human-like robot, which will also be Vyomnauts. Vyomnaut. This is a semi-humanoid. What is semi means? That is only upper part, not the complete one. Just half, torso. That will be the part of the machine there. Semi-humanoid. Vyomnaut. And what is our plan? They will stay in 150 to 200 kilometers in the orbit for 2 to 3 days and will be lowered back to the earth. They will land in the ocean and will recover them. That's what we are planning for this. So remember that from ISRO point of view, these 5 missions are important for the examination. These are 5 things which you have to read it just before the prelims exam. You have to go through it. Right? Any of this question could be asked in the exam. That is what the plan you have to be aware of. Right? That you have to be there. So don't worry, science and technology, whatever I'm trying to highlight here, the important points, that you have to go through it. You have to revise that one and make sure that these are topics you have done very well. Now what is very important, which I would like to add here, one area which is making a lot of headlines here, this one. Neutrino particle research. Now let me bring about 2 areas. One is this one, ice cube. What has come in the news? Ice cube. Now what is ice cube? Anybody in the classroom? What is ice cube? Anybody can tell me what is ice cube? Huh? No, that is all right. But what is this ice cube? Solid form water is all right. Yes, you are correct, very correct. But what is this ice cube here? Let me give it here. Antarctica. You know Antarctica, South Pole. Under Antarctica, 1 kilometer into 1 kilometer. Length, width, depth is not on the surface, under the surface. So it is basically this is a lab. Imagine 1 kilometer, you understand? From here, I think this RTC crossroad, Himayat Nagar. Imagine from here to Himayat Nagar, that distance length, that distance width, and also depth. Imagine this is like a room, you know, kind of a house, cube. That's called ice. Why is it called ice? Under the ice. Where ice? South Pole. And cube means that infrastructure. So here is a observatory to detect neutrino particle. Now neutrino particles, these are subatomic particles which are emitted from sun, stars. They're called cosmic messenger. What is called? Cosmic messenger. And they're very, very fast. Let me write here. Neutrinos, if you look at, travel close to speed of light. You know, light travels with 3 into 10 to the power 8 meter per second. It travels at around 2 into 10 to the power 8 meter per second. Now, what is about neutrino here? They are called cosmic messenger. Why they are called cosmic messenger? They are emitted by some kind of events in the universe. Emitted by supernova. What is supernova? When the star die, they burst out. Then it also emitted by neutron stars. Right? Then even black holes, etc. That means through neutrino, we can understand the universe event. But they travel very fast. Even now in the classroom, hundreds and thousands of neutrinos are crossing our body. We cannot see them. They are emitted in where? Universe. And they're passing through every object. Even through the room, wall, everything. They pass through everything. So they are very, very important from there. This is what they have done there. Now it is an international, remember that, it's an international project. Team of scientists from the worldwide, they are studying neutrino particles, that they are doing that one. Now what I'm bringing here, which is very, very important, you are aware of it. INO. That is the Indian Neutrino Particle Observatory. Right? Indian Neutrino Particle Observatory. Let me write here. Is an Indian neutrino particle. Because INO is in the news for a long time, but so far UPSC has not asked a single question on this particular topic. INO. And now this could be a question in the coming exam. Indian Neutrino Particle Observatory. Now we are constructing it. Where we are constructing? We are constructing inside a tunnel in a very important hill called Bodhi Hill. Where is Bodhi Hills? Tamil Nadu. So let me write here. Where this is being constructed, that is a lab inside Bodhi Hill. BODI, Bodhi Hills of Theni district, THENI, Theni district of Tamil Nadu. Now this is the part of Western Ghats. This forms the part of Western Ghats landscape. Now the question is, why we are doing it there? We are doing it there because it has got hardest rock. Now tell me, Deccan in the south is made of what type of rocks? Granite. Right? You have read in geography? Granite. Granite is a very, very hard rock. Igneous rock. Now imagine that hill is a granite, and within that, that is the hardest granite in the worldwide, not in India, worldwide. So what will happen when the neutrino particles will come to the hill? It will slow down. Speed will be slow down, and we will have a detector to capture neutrinos. So you can write number 2 here. It will use magnetized iron calorimeter to detect neutrinos. To detect a neutrino. Magnetized iron calorimeter to detect neutrinos. It will be magnetic field. Hundreds of them. They will create a layer, sheets of the iron plates. So when the neutrino will cross through that, it will be slow down and will be detected to understand universe. So a team of scientists from India, there's completely Indian project is there, and government of India has given fund for this. This project was stopped by NGT, National Green Tribunal, because it's a part of Western Ghats, and where this is being made? Tunnel. We are making a tunnel inside. So because of the ecological sensitivity in that area, wildlife and biodiversity, it was not allowed, but now it has been allowed. After giving, one area, EIA, environmental impact assessment, it has been now allowed there. But what is very important? It's very, very important from our scientific research. I know. Right? Where is the international project? This ice cube. Now, one thing which I will just add, which I've added last time also, but those who are new to the classroom, they know. This project also helps in understanding dark matter. You can write the study of dark matter found in universe. Even the ice cube that is looking for the dark matter. Right? Now tell me, those who were the last time, what is dark matter? I have explained that in the classroom also. What is dark matter? It is all making headlines. Dark matter. Yeah, dark matter is a matter. Matter means, solid, liquid, gas. The matter. There's a matter which does not interact with light. What does that means? Neither absorb light nor give light, give out light. No interaction. And what the scientists are saying? More than 10 times galaxy. We have galaxies, billions of galaxies. Even more than 10 times we have a dark matter. Imagine that. What we see the universe is just 4 to 5%. Remaining part is hidden. Dark means what? Hidden, which we cannot see. What we see? Galaxies, stars. But there are many parts of the universe which is invisible to us. So there one part is the dark matter. And they release what? Neutrinos. What is a particle here? Neutrino particles. Scientists will be able to understand. Right? So this could be a question in the exam. UPSC can ask question. What I put in a flow chart. So that you have to be aware of it. Alright? Clear there? This part is clear?